Welcome to the third introductory video for Module 5A. In this video, we will discuss factors of safety. Factor of safety gives us a margin for errors and inconsistencies that occur in the design, manufacturing, and construction processes. A factor of safety of 1 to 1 is what occurs at the borderline of the failure theorem diagram. So in the graph shown, the pink line is the 1-to-1 boundary of the von Mises theorem. We want to be well inside that boundary line. The distance from the boundary line is our factor of safety. The level of certainty that we have about the components, materials, and environment will drive our selection of factor of safety. Generally, for most applications, we want a factor of safety of at least 2. For applications where a failure is likely to result in injury to people, we often specify a factor of safety of at least 3. Where a failure will almost always result in death, think something like elevators for instance, we generally look for a 5-to-1 factor of safety. However, sometimes we are limited by the application for the level of safety factor that is practical to achieve. Flight systems are one example. You have 400 passengers on a Boeing 747. You'd like a 5-to-1 factor of safety, wouldn't you? But then the plane would never get off the ground. So what do? In this case, we seek to mitigate the level of uncertainty around the materials and processes. So, as noted in the chart, if we can test the actual material being used under the same environmental conditions, we can go with a factor of safety of 1.3. Oftentimes, however, testing involves destroying the component being analyzed. So for these situations, we may need to look at non-destructive testing or a destructive test of samples made from the same lot of material and manufactured using the same process. The paramount goal of engineering should be to advance and improve public health, safety, and welfare. That is why it is so critical that we use the correct factors of safety with appropriate modeling and testing as required. Many applications have their factors of safety defined by the various governing bodies for different types of mechanical designs. For instance, hoists and lifting mechanisms have their factors of safety defined by the American Society of Mechanical Engineers, or ASME. The Engineer's Creed is a motto developed to codify an engineer's role within the community. Engineering is not an occupation, rather it is a profession. A profession is a career path that involves prolonged training and a formal qualification. It is on par with becoming a doctor, lawyer, architect, etc. Note that the engineers to use their professional knowledge in the service of public health, safety, and welfare. The creed embodies honesty, standards of conduct, and service to others. Lastly, it calls for humility. Humility is the act of being humble, which means showing a modest or low estimate of one's own importance, thus putting the interests of others ahead of one's own. Another key part of humility is recognizing one's own fallibility, meaning that we can and will make mistakes, and we need to take appropriate action to correct our errors. That's it for this video. We will discuss the Engineer's Creed more in class.